Okay, so first I'm actually going to start with all the forces. So if I've got this ladder, on the floor it's resting, okay? So the floor will be providing a reaction force, perpendicular, normal contact force. That's the reaction of the ground at A. Yeah?
Yeah.
It's also resting on this thing over here. So there's a normal contact force, perpendicular again. That's the R at C.
Yeah.
So in another question, it would have an R at A, it would have an R at C. Yeah? In
Yeah.
another question, it would have an R at A, and it would have an R at B. Because it's called a normal contact force. It's perpendicular to the surface it's resting on, right? Now, the other forces down the middle, you've got the weight of the ladder. So that's the weight. And almost always the ground is rough. So the ladder would slip that way, right? If you were to let it go, it would slip, which means there's a friction going this way. And friction is equal to mu times the reaction at that point. Yeah, the equation for friction is the coefficient mu times by Ra. Okay, cool. Now, one thing we always like to do is just to make sure we've done our sine and cos. So if I know that I've got sine alpha equals 4 over 5, then I know that cos alpha. To do that, I can do the inverse sine of 4 over 5. I get 53.1 degrees. When I do the cos of that, I get 3 over 5. And that's going to help me later when I'm doing different components of different forces. Treat the question as a 10 marker, not as a 3 marker, because we need the diagram in general. And then the last thing I would say to do is to do all the distances before you carry on any further. So the whole distance is 6a, so this must be 3a, because the weight is distributed from the middle.
All the time, right? Unless it says that it's not.
Yeah, exactly. It would say uniform, but it's never been non-uniform, so you shouldn't hopefully have to worry. Otherwise, it will specify where the weight is. Then we need the distance from here to here, right?
Yeah.
This was the most challenging part of this question. It wasn't that easy to spot what that distance is. So to work out that distance, we had to use trigonometry. Now, we need this one. We know that the height is 4a. So we know this angle. That's the opposite, that's the h. So sine alpha equals 4a over h. H equals 4a over 4 over 5.
Oh,
Sokotoa.
okay.
But that was really difficult to spot. Every question will have a small trick that's different. It won't be like the last question. So we had to look out for that.
Oh, okay, I understood.
Okay. So 4 over 5 is 5. So we now know that this is 5a. I'm now just going to get rid of this. Okay. I've got my forces, I've got my distances. The forces are almost always the same.
Okay.
I'm just checking if it tells me anything else about the weight or the mu, or no, it doesn't. So now I can start. There are basically 4 things we can do. We can do forces up equals forces down. We can do forces left equals forces right. We can do moments around A. We can do moments around a different point. Most of the time we don't do this, we just do it about A, but just better to be safe and know that as an option.
Okay.
I don't have there's no set choice of which one to do. You have to kind of guess or figure it out based on your practice and your instinct.
Mm-hmm.
In this question, we need to find the reaction at C. So to do that, I think we should do the moments around A. Yeah?
Yes.
Okay. This one is mg, by the way. So before we carry on, I'm just going to add the angles, alpha, alpha, alpha. You won't need this one, but this is alpha as well. Are you okay with these?
Wait, can you explain to me again how I figured out which one is the sine? Not sine, which one is the alpha?
To be honest, I would recommend that you memorize this, but if you were stuck, the way you would do it is you would know that there is a Z angle here. So this is alpha because of the Z.
Mm-hmm.
This is 90 minus alpha. This is 90, so this is alpha again.
Okay.
But you're better off memorizing it because it's always... Alternatively, you know, there's many ways to work it out on the spot. The 90 minus alpha, and then this would have to be alpha, right?
Yeah.
Again, there's another Z here. So this is alpha. This is 90 minus alpha, making this one alpha.
Okay.
But it's always sloping in the same way. So if you've done it a few times, you'll just memorize it, I think.
Okay.
Okay. And then you can just make your right angle triangles. Okay, so alpha and alpha. Let's do the moment. So the equation for the moment is force times distance. Moment equals perpendicular... Sorry, one sec. Distance from the pivot times the perpendicular force. We're doing moments around A. So I've got mg cos alpha times by 3a. So I'm doing this one, which is the perpendicular one, right?
Yeah.
So that's mg cos alpha. The distance from the pivot is 3a. That's going like kind of clockwise. Any questions about that?
No.
Cool. And it has to equal
The
RC
yeah.
times by 5a. And I don't need to use cos or sine because it's already perpendicular to the ladder itself.
Wait, is RC clockwise? It's not, it's anti-clockwise.
Yeah, anti-clockwise. So then they have to be equal.
Okay. Yeah, okay.
And then RC equals 3AMG cos alpha over 5A. A's cancel. Cos alpha is 3 over 5. So RC equals 9 over 25 mg. And then part B says find mu. Do you remember the 3 things or 4 things we said? We said do moments around A. We said do forces left equals forces right.
Yeah,
Forces
first up equals first down.
So I'm going to now do forces left equals forces right because I need to get the mu.
Yeah.
So left equals right. I get to the right, I have,
mu r a.
yep. And then to the left, I have RC sine
But
alpha.
is
RC is going, I've got two components of RC. So I need the one going to the left. RC is going diagonal in this direction.
okay.
So that's going to be opposite. So it's RC sine alpha.
But the other red triangle, the W one, it's not going to the right, right? Because it goes just like it doesn't go to the
Yeah,
right.
you've got down the slope
Yeah.
and perpendicular to the slope and straight down. Nothing is going directly to the left in the
Yeah.
components.
Okay.
Yeah. So I can simplify the RC sine alpha. So RC, we worked it out, was 9 over 25 mg.
Wait, can you still write it as RC sine alpha? Is it because the opposite angle is pointing towards it,
Wait, sorry, what was your question?
right?
Yeah. You can go here and do your Sokotowa. That's your opposite. That's your RC is this one. And then that's your H. That's your A. So
Okay.
if you wanted to draw it separately, you could. So then we get 9 times 4, 36 over 125. So mu RA equals 36 over 125 mg. And then we can work out mu by dividing this by RA. The problem is we don't know RA, right?
Yeah.
So then what do we do? The third option was to do forces up and down. So I can do the forces up and down. So I get, wait, I'll write it over here. Going up, I have RC cos alpha. And I have RA. And going down, I have mg. Is that okay?
Yeah.
Perfect. So I know RC from the part A. Remember, if you couldn't do the part A, you could still use the answer and carry on. Don't forget that in exams to use the answer and continue.
Okay.
9 over 25 mg times by cos, which is 3 over 5, plus RA equals mg. I'll just solve this. RA equals mg minus 27 over 125 mg. So RA equals 98 over 125 mg. I'm going to plug it back here. So mu equals 36 over 125 mg divided by 98 over 125 mg. Cancel, cancel, and cancel. So 36 over 98. 18 over 49, or 0.367.
Okay.
Mu has to be between 0 and 1, otherwise you've done it wrong. So you'll know if it's right. Well, you should know if it's wrong. Perfect. Any more questions about this one?
No.
Okay.